Hello, students. Welcome to this week's episode of How to Do Triangle Things, featuring Pythagoras and his theorem. So, 6.4, Pythagorean Theorem Level 3. We've spent the past couple of weeks checking this stuff out. Let's go ahead and jump into the next one. Find a value of x to the nearest tenth. We've got multi-step Pythagorean theorem. So what we're going to do is, as always, we're going to take a screenshot so we can write on the screen. And let's go ahead and see what we can do. So it appears that this is a right triangle. And we know the hypotenuse in one of the legs. So what we're going to do is use the Pythagorean theorem to find what I'm going to call y. So since we have the hypotenuse, we're going to go with a squared plus b squared equals c squared. And we are going to go ahead and replace c with the number 10 because that's our hypotenuse, and a or b, not mattering which, with 9 because that's the other leg. So that means we have a squared plus 81 is 100. If you loop that around a little bit, you get a squared is 19 and a equals radical 19. So what we're going to do is now that's our hypotenuse, and we're now going to plug it in as our new c. So a squared plus b squared equals c squared for the smaller triangle, but now we're going to need to use our new variables. So c is going to be radical 19. I'm going to replace this with our 3 that we've been given. So a squared plus 9 is 19. A squared is 10. A equals radical 10. Or I guess that'd be x. But whatever variable we use, we're going to get radical 10. And that should round to 3.2. But I'll put it in a calculator to show. I'll move my head. Woo! 3.16 rounds up, and we get 3.2. We nailed it. What we need to do is sometimes we need to do the Pythagorean theorem more than once. And sometimes we need to show that like rectangle sides can move over in special ways. So right here, we're going to need to use that theorem to find this side here. So that'll be that side squared plus 25 is 100, so root 75 is going to be that third side. Because when you square it, you add it to the 25 you get from the bottom, and you get the 100 for squaring the hypotenuse. So if we square that, and we take away 9 from it, so 75 minus 9, you get 66. And x is going to be radical 66, or as some call it, root 66. So that'll be 8.1. And it'll show us the steps that we took to take that. 5 and y are the legs, hypotenuse is 10. Do all this shenaniganry to get 75, take the radical of it, and we get this. And note this thing right here, how it says leave it as a radical because converting it to a decimal too soon can cause problems with rounding. Find the missing leg of the triangle on top. And we do that by squaring this, subtracting 9, and taking the root. So in this next problem, we just do the theorem again. Square 2, you get 4. Square 3, you get 9. Take the root of that. Square that. Add it to 6 squared. And you get x squared. So radical 49 is actually just going to be 7. So these problems, you just have to do the Pythagorean theorem a couple of times. It's not that bad. It's like 4 and 5 give you 16 plus 25, root 41. Square it, add it to 36 for the squaring of 6. You get 77. Radical 77 in a calculator is 8.8. Sorry, didn't let me press the second 8. Okay, this is the other type of problem. This is why I skipped through all of them to get here. So when we're doing this, we don't need to do the theorem twice. We need to recognize that you can make a rectangle. Here's when taking the screenshots makes the most difference. Let's zoom in some, take the screenshot. Now what we're going to do is we're going to take this ruler and draw the fourth side of that rectangle, except for a little better than that. And what we get is, we know this is 3. We know that this is 6. So the rest of the 13, when you take away from the 6 on top, is going to be 13 minus 6, which is 7. So we've got 3 is one leg of the triangle, 7 is the other leg of the triangle, and x is the hypotenuse. So x equals radical 3 squared plus 7 squared is radical of 9 plus 49 is radical of 58. And that'll round to 7 point something. All right, so let's see what we get from that. I think that should be 7.6, but I'm not sure. Yeah. Okay, I would like to input an answer. Oh, I see. Numlock was off. But yeah, that's all you need to do for the first section. Hop into the next one. You've got a kite, so it's a little different. We want the length of AC to the nearest centimeter from a kite. Now what we want to do with that is we know that this bit here is 10 centimeters. So we're going to solve everything that we can about this thing. We want the length of AC, which is interesting here. So we are going to go ahead and find that this is 6. Each half of these is 5. Yeah. So each half of the 10 there is 5. So we have 2 Pythagorean theorems, one with hypotenuse of 6, one with hypotenuse of 9, each having one leg of 5. So what we're going to do is, to find this leg, we're going to get radical 36 minus 25, because 6 squared minus 5 squared. And to find this, we're going to get radical of 9 squared, which is 81, minus 5 squared. And we're going to get radical 11, and we're going to get radical, what is that, 56? And 56 is divisible by a square, which is 4. So if you take out 4, you'll get 2 radical 14. If we're just going to do to the nearest tenth of a centimeter, though, we're going to need to add these things together because the root 11 goes with this guy, and this thing goes with the other side. So let's simply add those. Root 11 plus 2 root 14. Calculator. 10 point, very convincing, 10.8 there. And we nailed it. We're going to get similar problems. We've got another kite. What we need to do with these is we simply cut that diagonal in half and then add up the 2 Pythagorean theorems you get by performing it with each side. So if we skip the nonsense, we end up with radical 5 squared minus half of 6, so 3 squared, plus radical 7 squared minus 3 squared. And that alone will get you 10.3, and that's all you need. So when you see these, right here we've got, what do you think? Radical of 8 squared minus 6 squared, because that's half of 12, and then radical 10 squared minus 6 squared. That's 13.3. That's all you have to do these problems. It takes literal 5 seconds to do each one. Radical 9 squared minus 4 squared plus radical 6 squared minus 4 squared. 12 and a half. Because 4 is half of 8. Just going through these just so you can see the repetition that it's pretty doable. Radical of 7 squared minus half of 12 squared, and then radical 10 squared minus half of 12 squared, 11.6. Done. That was all of those. Now finally, you start for driving north for 8 miles, turn right, drive east for another 6 miles. At the end, what is your straight line distance from your starting point? These word problems can be a little bit tricky, and your goal is to simply visualize where you end up in terms of how far east and how far north you go. So plus 8 north and plus 6 east. And that gives you radical 6 squared plus 8 squared, which is 10. That's going to be your distance. We did distance formula twice last semester, so you should be able to do it. The diagonal length of something is 40, so radical 40 squared minus, what's the other leg? 24 squared. We get 32. Done. I don't know why this television is going to be so much taller than it is wide, but that's their problem, not ours in solving it. If we know the diagonal length, we always subtract the other thing from it. So you're seeing that I'm going through these problems in a couple seconds each. Once you get what we're doing in this section, you're going to go through it this quickly. So you're going to do 13 squared minus 12 squared and take the root. Soon you're going to, once you've kind of clicks for you what exactly we're doing in this, you're going to just nail these every time. So we take that 41, subtract the 40 squared, got 9. And that's all it's going to take to do these problems. Okay, so 21 squared and 20 squared, we're going to actually have to add those because those aren't your diagonal. It asks you for the straight line distance, and it doesn't give you that diagonal, so you have to add. But when you had the TV problems, what you needed to do was subtract because you already knew the hypotenuse. 6 one way and 8 another way, you're going to have to add those and take the root to get the diagonal. But if you have the diagonal, you have to do a subtraction problem. As you see, I'm just placing these numbers into our equations, dropping them in. And in the time I've been talking to you, I've done an entire week's worth of homework. So I'm confident you can do the same. Have a good one, geometry kids.